Good morning, my dear students. In second year mathematics, today we have discussed the topic partial fractions. In partial fraction, we get the 4 marks in IPA exams. Okay, before start the partial fractions, we learn some basic concepts. Okay, first we discuss the polynomial. What is the polynomial? F of x is equal to a naught x power n, a n x power n minus 1 plus a 2 x power n minus 2 up to so on a n, where a naught is not equal to 0 is called the polynomial in x, where a naught, a n, a 2 up to so on a n are called the coefficient of polynomial. Examples for some polynomials: f of x is equal to 5x square plus 3x plus 2, g of x is equal to x plus 2, and h of x is equal to 3x plus 5, and f1 of x is equal to 5x power 4 plus 3x cube plus 2x square plus x plus 5 are called the examples for polynomial. Next we discuss the degree of the polynomial. F of x is equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 3 up to so on a n, where a naught is not equal to 0, then n is called the degree of the polynomial. It is denoted by order of f of x is equal to n. Okay, example: f of x is equal to 5x square plus 3x plus 2. Here order of f of x is equal to 2. Order of f of x is equal to 2. Okay, in this example, order of f of g of x is equal to 1. In h of x, the highest power is 1. That implies the order of h of x is equal to 1. In this problem, f1 of x, the order of highest power is 4. That implies the order of f1 of x is equal to 4. If order is 1, the polynomial is called the linear polynomial. If order is 2, the polynomial is called the quadratic polynomial. Okay, next, rational fraction or fraction. What is the rational fraction? In real number system, a comma b are any two real numbers, then a by b is called the rational fraction, where b is not equal to 0. For example, 1 by 2, 5 by 3, 6 by 4 are called the fractions in real number system. In polynomial, what is the rational fractions? If f of x, comma g of x are any two polynomials, then f of x by g of x, where g of x is not equal to 0 is called the rational fraction. Rational fraction or simply fraction. Okay, example for rational fractions. First example, 5x plus 1 by h square plus x minus 2. And second example, 5x plus 1 by x plus 2 minus 1. Next, third example, x minus 1 by 3x minus 1 by x plus 2 and h square minus x plus 1. And fourth example, h square minus 3 by x plus 2 and h square plus 1. And these are the examples for rational fractions or fractions. Next, we discuss the proper and improper fractions. In real number system also you have proper fractions and improper fractions. Okay, if f of x by g of x, where g of x is not equal to 0, is any fraction, okay, is called a proper fraction. Is called the proper fraction if order of f of x is less than order of g of x. Okay, is then f of x is called the proper fraction. Order of f of x is less than order of g of x. That means the order of the numerator polynomial is less than order of the denominator polynomial. Okay, if order of f of x is greater than or equal to order of g of x, then fraction f of x by g of x is called the improper fraction. Okay, for some example for proper fraction or improper fraction. In first example, order of f of x is 1 and order of g of x is 2. This is called the proper fraction. And second example, order of numerator polynomial is 1 and order of the denominator is 2. It is also proper fraction. In example 3, order of the numerator polynomial is 1 and order of the f of x is 1, order of the g of x is here is 1 and here 2, 3. Order of f of x is 1 and order of g of x is 3 and it is also proper fraction. And in this example, here order of the numerator polynomial f of x is 4 and order of the g of x is 2. That's why the fraction is a improper fraction. In example 7, same, the order of the f of x is 3 and order of the f of g of x is 2. It is also improper fraction. In example 8, it is also improper fraction. And it is also improper. And example 10, order of the f of x is 3 and order of the g of x is also 3. Okay, it is also improper fraction. Okay, order of the f of x and order of the r equal greater than or r equal to. Order of f of x is greater than order of g of x is also improper fraction and order of the f of x is equal to order of the g of x is also improper fraction. In these two examples, example 10 and example 11, order of the f of x and order of the g of x are equal, and it is also two examples also improper fractions. In real number, 1 by 2 is a proper fraction and 5 by 3 is a improper fraction. 6 by 4 is a proper fraction. First we discussed the fractal fractions for proper fractions, then we discussed the fractal fractions for improper fractions. Next we discussed the reducible polynomial and irreducible polynomial. A polynomial f of x is said to be irreducible if it cannot be expressed as a product of two polynomials g of and h of x such that degree of each polynomial is less than f of x. If f of x is not irreducible, then say that f of x is a reducible. Okay, some example 1 is simple example. If h square minus 1 is a h square minus 1 is a reducible polynomial. Why? H square minus 1 can be written as the product of the two polynomials h plus 1 and h minus 1. That's why h square minus 1 is a one reducible polynomial. And second example, h square minus 5x plus 4 is also reducible polynomial. Why? It can be the product of two linear factors and two linear polynomials h minus 1 and h minus 4. It is a reducible polynomial. It is also reducible polynomial. it is also reducible polynomial. And third example, h square plus 1 is not a, it cannot be written as the product of the two polynomials. That's why it is a irreducible polynomial. Irreducible polynomial. And example 4, h square plus h plus 1 and h square minus h plus 1 are also irreducible polynomials. Okay, next we discuss the fractional fractions of proper fractions. Proper fractions. Proper fractions means order of f of x is less than order of g of x. And in this first case, g of x has or contains non-repeated linear factors. Non-repeated linear factors. Linear factors mean, example, x minus a, x minus b, and x plus 2 and x plus 3 are called the non-repeated linear factors. If f of x by g of x in the form of f of x by g of x is equal to f of x by g of x in the form of x minus a and x minus b. Okay, here g of x is the two factors x minus a and x minus b. X minus is a non-repeated linear factors and x minus b also non-repeated linear factor. If x minus a whole square is called the repeated linear factors, that means x minus 2 whole square and x minus 2 whole cube and x minus 2 whole power 4 are called the repeated linear factors, or x minus 2 is the non-repeated linear factor. If given fraction f of x by x minus a and x minus b and g of x is a two non-repeated linear factors, then we taken as some constant a by x minus a and second one is b by second factor. It is the first step in fractional fractions. If given problem is in the problem in this way, f of x by x minus a and x minus b and x minus c, then it take as the first step, you take as capital A constant by and first linear factor plus b by second constant b by second factor and plus c by third one is x minus c. In this case we have discussed the only g of x as non-repeated linear factors. That means g of x is x minus a is the non-repeated linear factor and x minus b also non-repeated linear irreducible polynomial and x minus c also non-repeated irreducible polynomial. If in this problem if another one more factor x minus d is there here also and fourth constant d by x minus d, for example, okay, 2x plus 5 by x plus 1 into x plus 2. Okay, these are the it is a fraction, it is a proper fraction. Why? The order of the polynomial f of x is 1 and order of the g of x is 2. It is a proper fraction and g of x is non-repeated linear factor. That means x plus 1 is a non-repeated linear factor and x plus 2 is also non-repeated linear factor. Then we take some constant a by first linear factor x plus 1 and second one is b by x plus 2. If here x plus 3 also there, then we get the third constant c by x plus 3. Okay, it is the first step of in fractional fractions. Then First we write the a by x plus 1 and b by x plus 2 and c by x plus 3. Then we take in the constants a, b, c, d like that. First step is very very important, how to write the factors. Okay, second method, if g of x contains repeated linear factors and non-repeated linear factors, that is f of x by g of x is equal to f of x by, okay, that means x minus a whole square and x minus b. Okay, here observe the denominator, it is a proper fraction, x minus 2 whole square and x minus b. Here x minus a is a linear factor but repeated linear factor, and x minus is a non-repeated linear factor. Here take the some constant a by x minus a and second one b by x minus a whole square. This is the first repeated linear factor, and plus next second factor is a non-repeated linear factor. We take the another constant a, b, c. Next constant is c and second by x minus b. If f of x by x minus a whole cube and x minus b, and here x minus a is a linear factor with 3 times repeated. That's why you take the a by x minus a plus b by x minus a whole square plus c by x minus a whole cube, and second factor is a non-repeated linear factor. You take the another constant d by x minus b. Okay, next example, f of x by x minus a whole square and x minus b whole square. Here g of x minus a is a repeated linear factor and x minus b is a repeated linear factor. We take the a by x minus a plus next second constant b by x minus a whole square. If you have power 3 and take the c by power 3, and second factor is x minus b whole square. It is also a repeated linear factor. Here c by x minus b and d by x minus b whole square. Okay, these are the methods for g of x is a only non-repeated linear factors, and second one is g of x is a repeated linear factors. As third method, g of x contains irreducible non-repeated quadratic factors. Quadratic factors means ax square plus bx plus c, that is x square plus x plus 1 or x square plus 2 and x square plus 3 are examples for irreducible quadratic factors. For example, f of x by ax square plus bx plus c and x plus a. Then we take the here ax square plus bx plus c is a irreducible quadratic factor and x plus c is a irreducible linear non-repeated factor. Here take the ax plus b by constant is linear ax plus b by ax square plus bx plus c and another constant c by x plus a. For example, f of x by take the x square plus 2 and x square plus 3. Take the example f of x by x square plus 2 and x square plus 3. Here g of x has two factor, x square plus 2 is a quadratic factor and x square plus 3 also a quadratic factor, and x square plus 2 is a irreducible polynomial and x square plus 3 is also irreducible quadratic polynomial. We take the we take the constant ax plus b by x square plus 2, and second one is ch plus d by x square plus 3. If you have the leading factor, you take the constant a, b, c like that. If you have the quadratic factors, we take the constant linear format ax plus b and cs plus d format. And second one, if you have the f of x by x square plus 2 and x plus 1. Here g of x has two factors. One is quadratic irreducible factor and second one is linear factor. Okay, first we take the constant. It is a quadratic factor. We take the constant value ax plus b format by x square plus 2 plus second one is x plus 1. X plus 1 is a irreducible non-repeated linear factor. It is the first case. You take the only c by x plus 1. Only c by x plus 1. In the next case, f of x is a irreducible x square plus 2 whole square into x plus 1. In this example problem, x square plus 2 is a quadratic factor but whole square. It is a 2 times repeated. It is called the quadratic repeated factors. Quadratic repeated factor. You take the same as it is a quadratic polynomial. You take the constant is linear ax plus b format by x square plus 2. It is a whole square also there. That's why you take the another constant cs plus d by x square plus 2 whole square. If you have power 3, take the ex plus e by whole cube. And second factor is x plus 1 is a linear factor. You take the e by x plus 1. These are the basic concepts in properties. We recall the once again. Okay, g of x is a only non-repeated linear factors, and the second one is g of x is a repeated linear factors. Okay, and third one is quadratic factors. Quadratic factors mean x square plus a into x square plus b, and fourth one is 1 by x square plus a whole square into x plus d. Okay, first method is, okay, in this problem g of x is a proper fraction. First we discuss the only proper fractions. First we observe the g of x is a two non-repeated linear factors. That's why you take the x minus a, and x minus b also non-repeated linear factor. That's why you take the simply b by x minus b. In second example, 1 by x minus a whole square, but x minus a is a linear factor but repeated. That's why you take the a by x minus a and b by x minus a whole square plus x minus b is a non-repeated linear factor. That's why you take the c by x minus b. And third example, we have take the x square plus is the quadratic factor and x square plus b is a non-repeated quadratic factors. Non-repeated quadratic factors. In quadratic, we have take the constant is as a linear format ax plus b. Here the linear factor, we have take the constants only a, b, c. But here the quadratic equation and numerator, we take the linear format ax plus b by x square plus a, and x square plus b. It is also a quadratic factor. That's why we take the cs plus d by x square plus b. In this problem, x square plus a whole square. X square plus is a quadratic factor but repeated. That's why you take the ax plus b by x square plus a plus and cs plus d by same repeated factor. You take the x square plus a whole square and plus third one is x plus b. X plus is a linear factor. That's why you take the only e by x plus b. These are the basic concepts in fractal fractions. How to, it is a depending on only g of x, we not consider the f of x. Okay, first these are only proper fractions only. Okay, we have basic concept is depending on only denominator g of x. Denominator is non-repeated linear factors and second one is repeated linear factor, and third one is non-repeated quadratic factors, and fourth one is repeated quadratic factor and mixed also. Okay, in next class we discuss some examples about these four types of problems. First we discuss the first method is g of x as non-repeated linear factors. Non-repeated linear factors. Then we discuss the repeated linear factors. Then quadratic factors. Then fourth one is repeated quadratic problem. Some problems is mixed. Quadratics and repeated non-repeated linear factors. Okay, thank you.